Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a very interesting algorithm called as Adaboost. Even before I proceed to demonstrate how Adaboost algorithm works in Orange, my request you to subscribe to my channel, also like and share my videos. Let me begin by introducing the dataset to you. The dataset that I will be working on in today's video is called as tree_credit. This is a typical credit risk problem. I've got 7 fields in this spreadsheet. The very first field is customer ID. The second variable here is credit rating. We are looking at historical data of customers, and based on whether they have defaulted upon the payment of a loan or not, we are classifying customers as good credit risk or bad credit risk. So this is a binary class problem. Initially, you see a lot of customers being classified as bad, but I scroll down, you can see a lot of customers who have been classified as good credit risks. Now, after the second variable, you see variables like age, income, credit cards, education level of the customer, and car loans. All these are demographic details of the customer. Based on the demographic details like age, income, credit cards, so on and so forth, we would like to classify a customer as bad or good. To do this, we will be using an algorithm which is called as Adaboost algorithm. Even before I explain what is Adaboost algorithm, let's try and understand what exactly boosting means. In simple language, boosting is an ensemble modeling technique. I repeat, boosting is an ensemble modeling technique. The general principle behind boosting is first we build a model on a training data set. Then a second model is built to rectify the errors present in the first model. Let me repeat this. The general principle behind any boosting algorithm is to first build a model on the training data set. Then a second model is built to rectify the errors present in the first model. This procedure is continued until the errors are minimized and the data set is predicted correctly. The final goal or objective behind any boosting algorithm is to improve the overall accuracy of the model. With this introduction to boosting and the data set, let me proceed to open up Orange software. You can see here, this is the interface of Orange. It is a very user-friendly software. You don't need to write one single line of code to build a machine learning model here. So what is the first step in developing a credit risk model? The very first step here would be to load the data set. How do I load the data set? You can load the data set using a widget which is called as the file widget. You can see here the very first icon or widget that Orange displays is the file widget. Let me click on the file widget. Let me once again double click on the widget. You can see here the path is pointing towards the source file. The name of the source file here is tree_credit. It's a CSV file, and I have been able to load this file. Let me give you a general description of the data that I have. In this data set, there are 2,464 instances or records, which means we have 2,464 as the sample size, which is a healthy sample size to build a machine learning model. How many features do I have? I have 7 features, and interestingly, we don't have any missing values. Thirdly, the data has no target variable. We can always specify a target variable. It's entirely under our control. If you look at the second half of the page, Orange describes the variables that are present in the data set. The very first variable, as you can see, is ID. I've specified the role as skip because customer ID, social security number, Aadhaar card number, or PAN card number, or phone number, all these variables cannot be used as either the target or the independent variables for a machine learning model. And therefore, I will not be using the variable ID. The next variable, credit rating, you can see here, it's a categorical variable. There are two groups, 0 and 1. 0 refers to good credit risks and 1 represents bad credit risks. As you can clearly see here, I've specified the role as target. The rest of the variables may be age, income, credit cards, education, and finally, you also have car loans. All these variables are used as independent variables. Independent variables can be specified or taken in as feature. Therefore, the role for the independent variables would be feature, and the role for credit rating, the dependent variable here, is target. I've got one numeric variable, namely age. The rest of the variables are all categorical variables. Once you've made these selections, you can click on this apply button and then close this particular window. So congratulations. What we have done at this stage is to simply import the data set from a spreadsheet, and we have successfully loaded this file into Orange software. What's the next thing? The next thing would be to display the contents of the file. I've loaded the file. To display the contents of the file, what I will be doing here is I will simply right click on the canvas and type data table. You can see here, Orange displays an icon called as data table. You can just choose this particular option. Let me establish a connection between the file widget and the data table. All that I need to do is double click on the data table widget. The moment I double click, you can see here the 7 variables in my spreadsheet are being displayed here. The very first variable is credit rating. You can see here 1. The notation 1 refers to those customers who have a bad credit rating. And the notation 0 refers to all those customers who have a good credit rating. As I scroll down, you can see a lot of customers here have been assigned the value 0. As I told you, 0 represents good credit risks. The rest of the variables are pretty straightforward. They're all demographic details of the customer, like age, income, credit cards, education, and car loans. You also see a very interesting option, which is called as visualize numeric values. Let me scroll up. Let me just select the variable age. You can see here, there are long bars that are being displayed inside each and every cell. What do these bars mean? A very simple way to understand this would be longer the bar, larger the magnitude of the value in the cell. You can see here, there is a customer whose age is 63 years. 63 is on the higher side, and therefore you have a long bar. You also see for this customer, there is a blue bar because he belongs to the good credit rating. You can see there's an interesting case here wherein there is a red color bar. This red color bar is used to indicate that he is a bad credit risk. I'm not interested in this particular option, so I can just go ahead and remove the visualize numeric values option. So I can go ahead and close this particular window. So what have we accomplished so far? Simply put, we have imported the data set into Orange software using the file widget. And as a second step, we are displaying the contents of the file using the data table widget. Once we are through with these two steps, the next step is to use any machine learning algorithm. The algorithm which I will be using here is called as Adaboost algorithm. There are other algorithms as well called as XGBoost. You have gradient boosting method as well, but I will not be talking about these algorithms in this video. In this video, I would like to keep the discussion specifically focused on Adaboost. There are 2 or 3 points which I'd like to highlight about Adaboost algorithm. What exactly do we mean by Adaboost? Adaboost is short for adaptive boosting. This is one of the boosting algorithms. I repeat, Adaboost is short for adaptive boosting. This is one of the techniques under boosting. Adaboost can be used to boost the performance of any machine learning algorithm. It is best used with weak learners. Thirdly, Adaboost is a supervised learning technique. And one major advantage of using Adaboost is that it supports both classification as well as regression-based problems. These are some of the features of Adaboost. There are 2 major drawbacks or disadvantages of using a Adaboost algorithm. First, it needs a high quality data set. I repeat, Adaboost requires a high quality data set. Secondly, if the data is noisy or has outliers, Adaboost does not give good results. This is one of the biggest drawbacks of Adaboost algorithm, is that it expects the data to be clean and free from noise. Let's go ahead and call the Adaboost algorithm into orange. I'm just going to right click and choose the option Adaboost. Let me now establish a connection between the file widget and the Adaboost widget. This will ensure that the data is flowing from the file widget to Adaboost. You can see here, orange gives you a basic description of what an Adaboost algorithm is. It says it's an ensemble meta algorithm that combines weak learners and adapts to hardness of each training sample. Let me open up Adaboost. There are interesting parameters here, like number of estimators. You can always change the number here. The default number of estimators that is being used is 50. You can also experiment with the learning rate. By default, the learning rate is 1. You can see the algorithm that Adaboost uses. There are 2 options. If you're using a classification algorithm, orange provides 2 different choices. You can choose one of these. You can experiment with these hyperparameters. On the other hand, if it's a regression-based problem, you have 3 different loss functions. Either you can use linear, square, or exponential. When we say regression loss function, what we imply is that the target variable is a numeric variable or a scale variable. If the target variable is a scale variable, we can experiment with regression loss function. However, since I'm not building a regression model here, I will be using a classification algorithm. I'm going to go with the default option. Let me close this particular window. At this stage, using 50 estimators, Adaboost would have built a model. What is the next step? The next step is to evaluate the performance of the model. How do we evaluate the performance of any model? You can simply right-click and choose Test and Score. You can see here, this is the option that we have to choose to test the performance of the model. I'm going to establish a connection between the Adaboost algorithm and test and score widget. Once you establish this particular connection, the second thing that you need to do is you need to feed the data set into the test and score widget. Many times, this is the biggest mistake that beginners tend to make. They establish a connection between the machine learning algorithm and test and score option. That is good, but not good enough, because test and score, remember, expects two inputs. One, the machine learning algorithm, and second, the input data. So once you're through with this step, we are ready to estimate the performance of the model. What is the performance of this Adaboost model? Let me open up test and score. Now, you see a lot of interesting details to the left side. The very first option here is what is called as cross-validation. And under cross-validation, you can see the number of folds being specified as 5. This is entirely under your control. You can use a 2-fold cross-validation or a 3-fold cross-validation. Popularly, machine learning experts use a 10-fold cross-validation. Now, for this video, I'm going to go with the default option of 5. Let me draw your attention to this very, very important concept. What exactly do we mean by cross-validation? Cross-validation splits the data into subsets. You may ask me how many subsets. That depends upon the number that you have specified here. In the drop-down menu, if I choose 10, you can see here the numbers get revised. So what does a 10-fold cross-validation mean? Cross-validation splits the data into 10 subsets. After splitting the data into 10 subsets, it uses 9 for training the model. I repeat, it splits the data into 10 subsets and it uses 9 of these subsets for training the model and the remaining subset for testing it. It repeats this procedure 9 more times, each time using a different subset for testing. So this is what cross-validation, a 10-fold cross-validation does. Now, there are useful parameters to assess the performance of the Adaboost algorithm. You can see here the first item or the performance indicator that Orange displays is what is called as AUC. AUC stands for area under the curve. To be more precise, area under the ROC curve. If the area under the ROC curve is greater than 0.7, you can go ahead and claim that the model that you have built is a good model. On the other hand, if the AUC value is less than 0.7, it means that the model that you have built is not good. What is the AUC value that we have got? The AUC value that we have got is 0.73, which is greater than 0.7, and therefore we can say that Adaboost is good model in this case. Is this the best model? We have to test this claim by running alternative algorithms. Let's look at the second column, which is CA. CA stands for classification accuracy. Usually, a number which is greater than 70% is used to tell that the model accuracy is high. Here, roughly, we are getting 74% accuracy, which is a good sign. Again, an indication that Adaboost algorithm is able to classify customers as good and bad. Then you have the F1 score. F1 score is 0.74. F1 score is simply a harmonic mean between precision and recall. To calculate F1 score, we use a simple formula: 2 times precision multiplied by recall divided by the sum of precision and recall. Again, a value of 0.7 and above is a good number. Let's look at precision and recall. Precision is a very, very useful metric. How do we calculate precision? Precision is calculated by using a simple formula: true positives divided by true positives plus false positives. In the denominator, you have two terms, that is true positives plus false positives. Precision shares a very interesting relationship with false positives. What is this relationship? It has an inverse relationship between, there is an inverse relationship between precision and false positives, which simply means that if the number of false positives in the model goes up, precision comes down. Similarly, if the number of false positives go down, precision goes up. So this is the kind of inverse relationship that precision has with false positives. Again, we see a number which is close to 75%, which is a good sign. Lastly, we see what is called as recall. How do we calculate recall? Recall is simply true positives divided by the sum of true positives and false negatives. So you again have two terms in the denominator: true positives and false negatives. What kind of a relationship do you expect between false negatives and recall? Here again, we see an inverse relationship between false negatives and recall, implying that if the number of false negatives goes down, recall increases. On the other hand, if the number of false negatives goes up, recall decreases. So this is how recall and precision are useful, because they tell us the quality of the model. Overall, when you look at these 5 metrics, what can you conclude? Adaboost algorithm has done a good job. But is this the best model? We will have to check this by running alternative models. But most of the numbers are above 70%. So we can give a thumbs up sign to Adaboost algorithm. Let me close this particular window. Apart from test and score, there's another interesting way of evaluating the performance of any classification model. What is this? It is simply a confusion matrix. We can right click and choose the option confusion matrix. I'm going to establish a connection between test and score and confusion matrix. Let me open up the confusion matrix dialog box. You can see here, there's a 2 by 2 matrix. Along the row, you have 0 and 1, but this represents the actual category. This is the distribution of the dependent variable. Along the column, you can see this is the distribution of the predicted category. Predicted by who? Predicted by the Adaboost algorithm, which we have used. Again, you can see here, the algorithm has predicted 0 and 1. Question is, how do you evaluate the overall performance of this model? There's a very simple way to check the accuracy of the model, which is to look at the diagonal elements. Why the diagonal elements? Simply because the diagonal elements represent the correct classification. The off-diagonal elements represent incorrect classification. When the actual is 0, you can see here the predicted is also 0, which means out of 1,444 actual good credit risk customers, Adaboost as an algorithm has been able to classify 78% of these customers as good customers, which means that in predicting good credit risk customers, Adaboost algorithm is accurate to the extent of 78%. So 78% is the accuracy of the Adaboost algorithm that we have built for good credit risk customers. But many times we are not interested in identifying or predicting good customers because they are harmless. What we are interested in is predicting the bad customers simply because they are harmful. Let me look at the next number. You can see here along the row, it says actual and 1. And along the column, you have predicted and 1. The number that you see here is 68.8. If I round off, it is close to 69%. What does this mean? It simply means that out of 1020 actual bad credit risk customers, Adaboost algorithm has been able to correctly predict 69% of the bad credit risk customers. So 69% is the accuracy of the model when it comes to predicting bad credit risk customers. So this is a very, very useful metric, especially when you want to tell what is the percentage of correct classification for the harmful group. Let me close this particular window. We have looked at 5 different metrics in test and score, namely AUC, classification accuracy, precision, recall, and also the 5th metric. Let me just look for it. It is the F1 score. So these are the 5 different metrics which we looked at. Further, we went on to check the accuracy in predicting bad credit risks as well as good credit risks. The last thing which I'd like to do here is to simply use what is called as ROC curve. Let me right click and type ROC, which is nothing but receiver operating characteristic curve. So this is the curve that I would like to use to check the performance of the Adaboost algorithm. Let me open up the ROC curve. You can see here, we are interested in the class 1, which means bad credit risks. Let me draw your attention to the y-axis here. The y-axis represents true positive rate, which is also called as sensitivity. I repeat, the true positive rate, which is also called as sensitivity. In the x-axis, what we have done is basically we are looking at false positive rate or 1 minus specificity. You can see here the decile banding. When you see 0.1, 0.2, 0.3, this is nothing but the decile banding. This is the baseline. And this curve is very, very important. In fact, more than the curve, the area under the curve is quite important. Larger the area under the curve, better the performance of the model. Smaller the area under the curve, weaker is the performance of the model. We've already seen earlier that the AUC or the area under the curve is approximately 74%, which means that this is a good model. Let me close this. So at this stage, what we have is an Adaboost algorithm with a classification accuracy of approximately 75%. Most of the metrics look good. We have also further evaluated the quality of the model by looking at confusion metrics and ROC analysis. But remember, one of the biggest problem with Adaboost algorithm is that it does not perform well for noisy data. It needs a very good high quality data set, and only then Adaboost algorithm performs well. If the data has too many outliers, if the data is very, very noisy, Adaboost does not give good, reliable results. Let me compare the performance of Adaboost with any other algorithm. Let me right click and choose a decision tree. Let me establish a connection between the source file and decision tree. As before, I will again connect the decision tree widget to test and score. You can see here the algorithm has run. Let me open up test and score. You can see here the first row tells me the performance of the tree, and the second row tells me the performance of the Adaboost algorithm. As a general principle, boosting algorithm is expected to outperform decision tree. However, not in this case. Look at the performance of the tree. The decision tree has an AUC value of 0.77. The Adaboost algorithm has a smaller value. Its performance is 0.73. So when it comes to AUC, tree is outperforming Adaboost. When it comes to classification accuracy, the performance of the tree-based model is 76%. In Adaboost, it is 74%. Here again, when it comes to classification accuracy, tree is performing better than Adaboost. The same story goes for the rest of the metrics as well. When you look at F1 score or precision or recall, for a tree-based algorithm, we are getting better results as compared to Adaboost. This is a clear sign that Adaboost is not the right choice in this data set. Let me close this. We can further look at the confusion matrix. This is the old model Adaboost. Let me click on the tree-based algorithm. This is very interesting. When you look at the tree-based algorithm, the tree-based algorithm is good when it comes to identifying zero here refers to good credit risk. So the actual category is 0. The predicted category is also 0. So the performance of the model in identifying or in predicting good credit risks is 82%. Let me compare this with the Adaboost algorithm. Adaboost algorithm gave us only 77%. So when it comes to identifying or predicting good credit risk, clearly tree-based model is outperforming Adaboost algorithm. Now, for the tree-based algorithm, let us look at the performance of bad credit risk. It is 67%. I repeat, it is 67%. If we go back to Adaboost, the Adaboost algorithm gave us an accuracy of 68.8, roughly 69. This is very interesting because Adaboost is doing a better job than the tree-based algorithm in identifying bad credit risks. Its performance in identifying bad credit risk is much better than the tree-based algorithm. Let me close this. Let's finally do a comparative analysis for a Adaboost algorithm versus a decision tree model. We can look at the ROC curve. You can see here, the green line represents Adaboost algorithm. So this is the Adaboost algorithm, and the red line indicates the performance of the tree-based algorithm. So when we plot both of these algorithms, initially there is not much of a difference. However, clearly the red line is outperforming, which means that the tree-based algorithm has a slight advantage as compared to an Adaboost algorithm. Further, there is an increase or betterment in the performance of the tree-based algorithm as compared to Adaboost algorithm. So there is a marginal increase consistently that you observe for a tree-based algorithm as compared to an Adaboost algorithm. With this, I have come to the end of today's video. In today's video, we looked at what exactly is boosting. We went on to perform credit risk analysis using Adaboost technique. We discussed some of the important features of Adaboost. We also spoke about the disadvantages of using Adaboost. Remember the two big disadvantages: it requires high quality data and it does not function well when there are too many outliers and the data is noisy. Further, after building the Adaboost model, we looked at different model diagnostics. We evaluated the performance through confusion metrics and ROC analysis. And to check whether Adaboost model is the best model or the champion model, we compared Adaboost model with that of a decision tree. For most of the metrics, a decision tree model in this case outperforms a Adaboost model. With this, I have come to the end of today's video. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much. Have a great day ahead.